the International Faculty Development Program on AI and Machine Learning in Medical Imaging, a Python-based approach 2025, scheduled from June 3 to June 7, 2025. I welcome you all. Please join me in warmly welcoming Dr. S. Venkatasubramanian, Associate Professor, Department of Computer Science and Business Systems, Saranathan College of Engineering, Trichy, Tamil Nadu. With his extensive expertise and academic contributions, Dr. Venkatasubramanian sir, once again welcome you, sir.
Thank you, madam.
Okay, sir.
Can I start my session? Shall I start my session? Hello, madam. Can you hear me? So, very good evening to the audience, the participants. Thank you for introduction about the speaker. So today I'm going to talk about the machine learning. I have divided my session into two of one. The first part I'm going to deal about the introductory concepts of machine learning, how the machine learning is helpful. Then I'll be giving you a demonstration about how to do this basic machine learning coding using this Python. So that is my agenda of today's. So the machine learning is that the human being, when you're born as a human being, let's say that you may be in your lap of your mother, and your mother try to take you outside and show you the goats, and she says that this is a goat. So you remember, okay, if a particular animal looks like that, a black, that is a goat. And some other day she will be showing another goat will be white in color. You will also register, okay, the goat will be in black color and white color. In some other day, the mother will show you a goat which is having a multiple colors. Then you register. So you are trying to, from the childhood, you are trying to learn from the surrounding that registers in your mind. The goat will be like this and will be of the different colors. Afterwards, once you grow, you see any other goats which is other than whatever is registered in your mind, any other color which is other than whatever is registered in your mind, you can identify that as called a goat. So this is what exactly is the intelligence, human intelligence. That means you try to learn from the whatever the learning that you have made in the childhood. You are trying to do what is called a kind of a prediction, and this is what is called human learning. The same thing we are going to make it into the machine. That means we are going to give the machine a kind of the learning environment where we are going to use different types of data. The machine learning, which is very, very important, is the data is important. We are going to feed the software with what is called the data, and we are going to make the data, the software to learn about the data. From the learning, in the future, whatever the data is going to be fed to this particular machine, that can be a new data, but the software is going to predict from the learning what exactly is the factual information about that particular data. So this is the overview of what is called the machine learning. So the machine learning is a field of study that gives you computers the ability to learn without being explicitly programmed. We basically write some kind of a program to try and make the system to learn by itself, feed a lot of data to the system. With whatever the data that has been fed to the system, the machine learning will try to learn. So when we talk about machine learning, again, it is one of the artificial intelligence domain, because artificial intelligence is a generic, very, very big domain, and the machine learning is a part of this artificial intelligence. And if you want to be very specific about your learning, then we have a subset of machine learning. What we have, what is called the deep learning, and a part, if you're very further, very specific about even a specific thing, Then we go for what is called this generative AI and other things which keeps going. So artificial intelligence is the big father for all these kind of technologies. What we do is that, so let us say what is the difference between our programming, the human learning, and what is called the machine learning. Okay, so what we do is, as I said, we do the observation, we try to learn, we try to make them classify, this is what, this is this animal, this is this animal, this is this human being, all these things. We try to, doing the observation, we try to learn, and then from the learning we try to exhibit our skills to show off your intelligence. And machine learning, what we do is, we, instead of observation, we feed the data, and the machine learning will try to use a model, and which is also sometimes called as a predictor, and that model is going to use the data, consume the data, and which is going to predict what exactly is the fact about the new data. So this is very, very, very important difference between the human learning and what is called this the machine learning. And another important thing is that, what is the difference between the programming and machine learning? In programs, what we do is, we know very well what a program should do. Okay, we'll be giving an input, and you use the input in formula, and we know that what should be the output of that particular program, and we check whether this particular output matches with our output. That is what is called the programming. But machine learning is not something like that, where we are trying to give the input and try to use some formula, something else, where we feed enormous amount of data into it, make the system comfortably to find out the facts in the data. Then given a new data, the system will try to tell, hey, I know this data, I know this particular information. Now I can predict, or I can tell you what is the new information which is given to me. How can I tell? Because I have already learned from the huge amount of data. So what is very, very, very important for the machine learning is that the model or a predictor. So the question arises, what is a model? What is a model? Is it my screen visible to everybody? Please give me a feedback. Is my voice audible? Is it clear? Should I have to go slow down?
Yes, sir. It's audible, sir.
Okay, okay. Shall I go ahead? Okay.
Yes, sir. Okay, sir.
Okay. So what is a model? A model can be anything. What exactly it may be a mathematical equation, or it may be relational diagrams like a graph or a trees. It can be a logical if-else rules to the very simple concern. It can be even some kind of a grouping. We call it as a cluster. Anything is what is called a kind of a model. So we use this model to do what is called the prediction of data. So with the machine learning, what we do is the system tries to learn, that tries to predict. And one more thing is that the prediction may not be correct. The prediction may not be accurately correct. And whenever it wants to improve, whenever the prediction is wrong, or the prediction is slightly lagging or leading above the original value or expected value, the machine learning tries to improve itself by taking more learning process. That is the beauty of this. So the bookish definition of machine learning is that a computer program is set to learn from experience. We call it as a E. With respect to a task, whatever the task we want to do, for the doing the task, we learn from the experience. And when we learn, even when the school or colleges and we learn, we should know that how do we perform. So exams are being conducted. From that, we try to know the performance. So there is a particular kind of a learning from the experience. For what? The particular task. And have we learned properly or not? There must be some performance measure, P, and how exactly it performs. So it performs on the task measured by the performance to improve the experience of learning, because that learning is very, very, very important. So the three components of this definition are the experience, which is what is called the learning, the task for which we are going to learn, and the performance measure. Are we learning it correctly, accurately, or is our accuracy is very near to our actuals? So when we talk about this machine learning, the data is a very, very, very important component of machine learning, because what we have now, the humorous amount of data. Take, for example, very simple example, a flight which is moving from Madurai to Chennai, which is carrying about 200 passengers. Now, from the reservation to the luggage checking, to the passengers who are checking in into the flight, to boarding into the flight from taking off, while flying, landing, again deboarding from the flight, and the passengers checking their luggages. So this is the entire process. For the entire process, the amount of data which is being used by the airlines just for only one flight, which is flying from Madurai to Chennai, which is hardly about 450 kilometers, and it uses more GBs of data. Okay, now think about the airlines which are being operated from various cities between various countries. The data which is getting accumulated per day is humorous. Now, importantly, when the data is accumulating, we need to process the data. That's where exactly the data science comes, the data analytics comes. Now, how do you? Hello?
Yes, sir. Sir, presentation screen is not visible, sir.
Not visible. Oh, okay. Just I have shared the entire screen. I'll do it again. Is it okay now?
Yes, sir. Now okay, sir.
Should I have to go back and then review some of these slides?
No, sir.
Okay.
Need for machine learning screen visible, sir.
Okay. This is
It's enough, sir.
okay. So the data is very important, and when we talk about analyzing this data, and what exactly happens here is that we need to apply this machine learning into the data. That means we need to apply this AI. So what exactly happened is we are in the bottom of this particular screen. We are here basically. The data is in a raw format. I told you the example between the flight flying from Madurai to Chennai. What exactly we have? We have the raw data. It has a facts. Data has a facts and symbols. And what exactly we need to do? We need to extract the important information from the data. We call it as a information. The important facts from the raw data, which is called as a information, which is a processed data. Further, when we go and analyze the information, we get some kind of the knowledge. It is a condensed. Okay, this is what exactly the base. And what exactly we require now is that from the knowledge, we need to apply this knowledge to make our system intelligent. Of course, wisdom is not for machines, but it's only for human being. When the humans are intelligent, what exactly they will get is what is called wisdom. But we are not talking about machine wisdom. We are talking only about machine learning. Okay, so for processing this data, we require machine learning. And when you talk about the case study, the use case of machine learning, this has been applicable to various studies. And the current topic of our workshop is about how to make the medical diagnosis possible using what is called machine learning. But other than that, we can also go for the house rate prediction, the real estate application, traffic prediction, search engines, all the stuff, spam folder, spam mail reductions, all this. If you see that, Airtel has implemented, I don't know about others. In Airtel, I'm using Airtel because whenever some kind of junk calls comes, automatically it says that it is a spam call. Okay, so the number which is very, very unusual, the machine learning in the Airtel, it need not be spam, but it try to detect it as a spam and try to promote or trying to display that particular number as what is called spam. So accordingly, we can react. So this is again one of the machine learning technique which has been used practically in our cellular providers, service providers. So the data, when we talk about the data, can be as the quantitative and qualitative, which can be a numerical, which is made up of numbers, something like a weight, number, children, shoe size, and the heartbeat rate. Okay, the categorical, which is made up of words like eyes color and the petal color, and the blood type, all these kind of things. And when you talk about numerical, the numerical data can be continuous. That means there is a relationship between the first data and second data, and it is what is called the discrete. That means the samples of data is available. There is not much correlation between the data, which is a discrete. Similarly, when you talk about this categorical, there are two types. One is the ordinal. Data has an hierarchy. That means one data is associated with another data. For example, the pain is severe, BP is increasing, pulse rate is decreasing. So there is some kind of the relationship hierarchical between what is called this data, which is ordinal. Nominal means the data has no hierarchy. but they are basically being used for predictions. So this is how we classify the data into a numerical and categorical. So coming back to the basics of machine learning, when we talk about this machine learning, we talk about three types of learning. One is called as supervised machine learning. The machines learns from the training data, that data, whatever we are trying to provide to what is called the machines. Then second is what is called unsupervised learning. Again, we may give a data, but we need not show to the system, the software, this is what category of data it is. Sometimes we even need not give a training data, it try to learn by itself. Again, very specifically, we have what is called the reinforcement learning. The machines, the algorithm try to learn, the model try to learn of its own by giving some kind of a credit. For example, it learns correct, it gives a kind of a credit. It learns wrong, it try to give some kind of a punishment. Like this, credit and punishment, reward and punishment, like this, it try to provide. That is what is called the reinforcement learning. This is the main three classes of machine learning with respect type of learning with respect to the machine learning. So, for example, where exactly you go for what is called supervised. So, whenever our data is labeled, so what do you mean by labeled? Now you can see two examples. One is having a very table. A table shows the data of a particular flower, the length of the petal, width of the petal, and the sepal width. From that, we can identify it belongs to a class called a Satosha. So like each and every data, we are trying to classify this flower into what is called the different classification. Another simple example, let's say that the label we are giving for what is called this kind of dog, we are giving to the cat as what is called cat. That means we are describing the data with a label, which is what is called labeled data. Now, whenever we deal with the label, we have a labeled data. That's normally we'll have a labeled data. Any RDBMS will have an attributes, all these kind of stuffs. So when we have a labeled data, you just send that particular labeled data into a model. That model is now a classification algorithm. Okay. And now this particular model try to learn from the labeled data. Okay, enough of data we are giving to this model. More the data you train your model, better will be the performance. After learning, you give a new data to this particular model. You give a new data to this particular model. If your model is learned enough and your model is accurate, it try to predict that whatever the new data you are giving is a cat. Okay, as per this picture I'm telling, it's a cat. So prediction is very, very, very accurate. The prediction is very accurate. So supervised learning works with what is called the labeled data. The labeled data, the data are given some kind of a descriptions. Okay. Next is what is called unlabeled data. The data which is not associated with the label is called unlabeled data. For example, there are two pictures. Since we know which is what, but machines may not be knowing because we are not giving label. In the previous label data, we are giving the label along with the pictures. So the machine knows what it has. Now the machine do not know what exactly it is. This is an example. Now, how do we do that? Say similarly, we have a model. Let us say the clustering model, which is one of the machine learning model. We are sending unlabeled a huge amount of unlabeled data to the model clustering model. Now the clustering model classifies and seeing some features. It classifies these are belonging to one class, these are belonging to another class. Whenever we are giving a test data, it says that this particular test data belongs to either cluster 1 or cluster 2. Then we can say the cluster 1 is belongs to cat category, cluster 2 belongs to a dog category. So this is what is called unsupervised. So unsupervised learning works with what is called the unlabeled data. So when we talk about the classifications of machine types, we have a supervised, unsupervised, semi-supervised, which is between supervised and unsupervised, and then reinforcement learning. So the supervised learning, yes, it will work with the continuous data as well as what is called the categorical target variable. And some of the important models are the regression, about which I am going to give you a demo today. And the second is what is called a classification. Probably the speakers of tomorrow, day after tomorrow, will be giving about this. For example, regression, a typical example is I want to predict the house price. This is the area. These are the amenities very near to that. So what could be the price of this particular house? Classification, medical imaging. The crux of this particular workshop, the medical imaging is one of the important application where it uses a classification and we use a supervised. The unsupervised means the label is not available, the target variable is not been defined, and the technique we use, the model we use is the clustering and association. For example, this text classification, so we are writing some signature and we try to detect the signature, all these things. So we have a clustering and we have what is called the association associated with the relevant data, maybe a GPS data association. A categorical target value is being used in semi-supervised. Again, it uses classification and clustering. Again, typical application can be text classification and the GPS classification. And very important learning is what is called the reinforcement learning. Again, it works with both the categorical target value, non-categorical value, and it uses a classification model and control model. And typical examples are optimized marketing. It tries to say is that I'm trying to sell the ice creams in a particular place where the temperature is always below 25 degrees. At what season I can go and sell this, what is called this ice cream? This is typical a marketing question. So the classification will try to help me in suggesting the marketing team when exactly I can go and pinch my sales into those regions. Similarly, you heard about the Google driverless cars, which are examples of the reinforcement learning, which is using the model as a control as a model. Sorry. Okay, so to revise, so far what we learned is that we try to give data as an input, and it analyzes the data and try to find some kind of a relationship between the data. Yes, it can be either classified data, or it can be some kind of a correlation, a relationship between the first data and second data, some kind of a patterns it finds, and use that particular pattern to predict. And once it predicts, it sends the feedback. What is the error in the prediction? How much the prediction is differing from the actuals? It sends back and then try to correct the learning. So let's say that I want to talk about the dogs. I am giving 5 dogs picture. It try to learn. 6th dog I am trying to test with the system. System says it is not a dog, which means that learning is not proper. So I have to give more data to the system, make the prediction possible. Fine. So now I want to work with the machine learning set. So what are the tools I require? Now, any tool can be used, but there are tools which are predominantly used by researchers and students and people who are doing the projects. One is the very basic tool. One is a very basic tool, which is ideally, whenever we install the Python, this ideally will be installed along with this particular thing. The second is Jupyter, which is very widely used, and even with the AI, we have what is called the Spider and other things we have. And very comfortable tool is that we have an online tool, which is a Google Colab. I'm going to use this Google Colab today, but everything you can use, anything you can use. This is very basic. This is very comfortable. It should be installed in your local system, both. And when you just download a package called Anaconda, these will be installed automatically. And if you want to work with online, so I don't want to restrict to my system. Today I am working in a research lab. I go evening to my home. I want to continue my project. What shall I do? Then this online platform, Google Colab, is very comfortable. So with these particular basics, I go to the first machine learning model, prediction model. We call it as a regression analysis. So what exactly a regression problem is? Regression is a very simple way by which we try to do the prediction. Now here there is a relationship between a variable x, another variable y, by a factor theta. Yeah, mathematically we call this as what is called the regression function, and still I will clarify this because it's a theoretical first approach I am doing it, then I'll go for what practical things. And this is one thing which is called a dependent variable. This is what is called an independent variable. Okay. So when the value of this x changes, the value of y also changes. So this is an independent variable. and this is what is called the dependent variable. Okay, so this is the basic equation that models what is called the regression. Especially there are so many types of regression, but the general regression is basically been modeled like this. And a regression analysis is a kind of a supervisory learning where it is going to use the labeled data, which is the form y equal to f of x. X is an independent variable and y is called a dependent variable. So where this regression analysis is basically try to show the relationship between the variables, how far these variables are correlated, having some kind of a relationship, strength relationship, and what type of relationship, whether they are linear or non-linear. That means when x increases, y also increases proportionally. That is, it's a linear. X increases, y also increases, but it is not proportional, which is a non-linear. Okay, for example, 5 people are using it, the current is, let's say, 2 units. 10 people are using it, the current is 4, 5, 6 units. So there is a kind of a relationship, linear relationship. Okay. What is the relevance of the attributes? So how the attributes are very important, and in what way the contribution of each attributes to the regression analysis to make the prediction more accurate. So there are so many varieties where regression can also be used. As I said, it is to estimate my salary. My experience is this, I am getting this. After 5 years, my experience increases, what will be my salary? What is the price of this particular house in this area after 2 years? What is my share market? Now I have invested it. This is the current scenario of the stock market. After 5 months, what will be my stock market, my portfolio value? And what is the how much the premium of the insurance company will go up or go down? How much yield of crops in agriculture? So these are all the various applications, even including the medical. How can I predict the heart attack? All these things you can do that. So if you talk about these 3 pictures, there is this x, which is an independent variable, y, there is a dependent variable. If there is a relationship is linear, each and every point is a data. For every point of x, there is a value for y. And when you increase this x, there is a corresponding increase in this y. So this is what is called the linear or a positive correlation. Okay, so the relationship is positive. There is a positive increase, positive increase. You can see here there is a positive increase of x, but there is a negative increase of this y, which is called as a negative correlation. Here it is distributed for different values of this x. We cannot predict. As x increases, will the y increases? No, the y is not increasing. So there is no correlation between this x and y. So these are the different types of relationship between the data or the 2 variables, which has been given in this scatter plot. Okay, the same thing I am showing here, the linear and non-linear relationship. So everybody knows about the straight line equation, y equal to ax plus b, and which is a linear, and it can be exponential or it can be logarithmic, which are all examples of what is called the non-linear relationship between the data. When we talk about this machine learning, we are trying to train the data. Okay, and what happens? The outcomes, there are the predicted value will come as what is called the output. When we get the output, there are 2 parameters which are affecting. It can be told as what is called 2 important keywords. One is this underfitting. When the model cannot accurately capture the dependencies among the data, y equal to ax plus p, that's a dependency between the data. The model cannot accurately capture it. Model cannot understand what is the relationship between the data. Then it yields a very low value, and we call this situation as what is called the underfitting. Similarly, when the model learns both the data and dependencies and the random fluctuation, the model is learning too smart that always the prediction is always above the normal value, which we call it as what is called the overfitting. So underfitting and overfitting are the 2 parameters which we'll be using predominantly in what is called the machine learning. So when we talk about the regression, we are now talking about a very simple machine learning model called regression. So we know that the regression can be a linear regression, a non-linear regression, and logical regressions. The linear regression can be of 2 types. One is called a single linear regression, very simple type. And second is what is called multiple linear regression. And the non-linear is what is called a polynomial. Okay. Logical, it is a logistic, which is called as a logistic regression. Okay, let us go for a simple linear regression. The model will be in the form y equal to ax plus b, multivariate linear, multiple linear regression where the parameters are not only one independent variables. There are so many independent variables x1, x2, x3, x1. So the value of y not only depends on this particular one value of x, but so many values of y. We call it as the multivariate regression. The polynomial, it is where in what is called the exponential form. It can be in the exponential form. The dependent variable depends on the power of what is called the non-dependent variable. Finally, the logic regression, it is basically a probabilistic in nature. The dependent variable will be in a probabilistic, may occur, may not occur, or something like this. So this is what is called the logistic regression. So the basic medical diagnosis uses all this type are basically the logistic type, because heart attack may arise and may not arise. When exactly it will arise? So there are so many parameters. Okay, well, let's go to this particular case afterwards. Let us talk about. So the linear regression of the basic form a naught plus a1x, a plus bx, plus we introduce a term called e. The e is called error. Always whenever we try to predict from the actual value to the predicted value, there is a very small gap. If the small gap is there, it's very okay. But what exactly is the difference is what is called the error. So we also try to make that error to appear on the expression. Why? Because I have told you already that whenever the machine learning try to predict, depending upon the correctness of the predictor, it has to get the feedback. The error is what is called the feedback. It has to, only if the model knows what is the error, it try to minimize what is called this error. So the E is also been taken as the consideration. Normally the general equation is A naught, one constant, A1 x. So A naught and A1 are two important coefficients. We call it as a coefficients. Okay. So instead of going for this particular theory, let us go directly into some kind of a practical case. So this is the errors. There is a line and the values are there in this is what is a predictor. The straight line is what is called the prediction, what we expect the values to be, but where exactly the actual values are here and here exactly, and this difference between the actual value and the predicted value is what is called the error. Okay, so we are going to do, we are going to build up a model where the two coefficients a0 and a1 we are going to find. Because x is the value we are going to give as a data, y is the value which we are going to predict, y equal to ax plus b. Okay. So what is this? We are going to say a1 and a0. The linear regression model, we have to find out a1 and a0. What is that a1? You take the value xy, product it, take the average, minus average of all the x input value, average of all the predicted value, divided by the square average of x and average square of this x. So this is what is called A1. We'll do it. We'll do the step-by-step example. And A0 is given by the average of y minus this x bar. We have found out A1 in the previous step minus A1 into average of all the x. So this is the two coefficients we are trying to find. Once we find this A1 and A0, we are going to substitute this A1 and A0 in the equation and we are going to predict the value. Okay, let us take the simple data, the labeled data. I'm doing some sales of items every week. Okay, I'm taking some data. The first week, the sales in thousands is 1.2. The second week, it is 1.8. Like this, I have a table. So there are two data. Depends on the week, the sales either increase or decrease. Okay, so when I give the x, which is what is called the dependent variable, I can get what is called y, which is what is called the independent variable. Now, my intention is, I have this, I want to predict what could be the sale in the 7th and 9th month, which is not available in the table. Okay, which is not available in the table. What is the prediction value of 7th and 9th month sales? That is my intention. Okay, so we have the week column and we have what is called sales in 1000. X is independent, Y is dependent. So first step we are going to do is that whatever. So I just shown you in the formula how to find the A1, how to find the A0. So we have to have XY, product, average it. Xy bar minus x bar into y bar. Average of x and average of y. Then x square bar. Take the square of each and every value, take the average of this. Then average of this x, then the square. Okay. Now what we do is, I have done with the Excel. I show you this sheet. But in the from the table I have taken first week 1.2. You can see that first week 1.2. This table I have taken. This is x. This is y. Now I am taking the x square of this x. I am taking x and y, multiplying this and this. So I am taking the sum of this column, sum of this, and sum of this. Average, because I want x bar. Because in formula, I have to use x bar. I have to use y bar. I have to use the average of this square. So that's the reason why I have taken this. Okay. Then multiply x and y, and I have to take average. Sorry. Is it the table clear? The reason why I am forming this table, this is the equation y equal to a plus a1 x. I have to find the value of a1 and a0. So this is table is used, x and y is used. So for finding all these things, I use this computation table. Okay. Then all the values are found out, and from this formula, a1 equal to xy bar minus x bar y bar divided by xi square bar minus x bar square. All the value we are computed in a separate column. Just substitute. We get a1 equal to 0.66. Then a0, again the formula value is given, y bar minus a1 into x bar. So all these values we are find out. So 0.54. Now all these values are calculated. Now y equal to 0.66x plus, because a0 plus a1x. a0 is 0.54 plus 0.66x. Now any value x, now you substitute here. Any value. Okay. Y is equal to 0.66x plus 0.54. Any value of x you substitute, you will get what is called y. Now what we want to predict the 7th week sale and 12th month sale. Okay, 7th or 12th week sale, whatever you take. Now x will be 7. Substitute 7 in the formula. Y equal to 0.4 plus 0.66 into 7, which is 5.16. So in the table, in the 7th week, it is 5.7 thousands. So prediction is over. 5.16, sorry, 5.6 is over the prediction. Similarly, 12th, you substitute 12th in terms of x, you get what is called the value. So this is what is called a linear regression. Now error, I told you, no, between the prediction and actual value, we have to find the error. That error is what is called mean absolute error. Y cap is what we have predicted. Y is what is the actual value. What is the difference between this? You take all the differences you get for all the data, take the average of this, which is what is called mean absolute square. Mean absolute square. Okay, shall we go to a demo? Okay, now what you do is you go to colab.google.com. colab.google.com. So you'll get this, and I already logged in. If you have everybody should be having Gmail ID. So using the Gmail ID, log into it. Okay, you log into this, because if I log out, then my meeting will get logged out. So this is the screen. If you have Gmail ID, just log into it. It will be showing you here login. Just log into that. It will show you your Gmail ID. Then you go to what is called the new notebook, open new notebook. Okay. It will show something like this. You can give, either you can give anything is there, you can just open, or you can just open the new one. Okay, you can open what is called new one. Right. So I have already done it. For the time's sake, I'm opening it. Okay. So you can give a title, whatever it is. Now, how it will be, I'll show you. It will be like this. Empty. It'll show the empty. Here you can do the coding, and you can just press this run button. It will run. Then and there it will run. Okay. If you don't want this window, this is a code window. If you don't want this, you can just select it, and you can just go and click on the delete. Okay. What is the very first thing we require? We require the data, because we are going to train the system. We require a data. So what I do is I take a very simple data which is in the CSV form, comma separated value form. There are two columns here. I'm doing a simple regression. This is X, this is Y. Years of experience is X, Y is salary. I have a simple CSV file, comma separated value file. I call it as a salary data. It is in my local system. It is in my local system. Okay, it is in my local system. Now I have to import this data into the Colab, because I am working with the Colab, which is running in the Google Cloud. So it doesn't know anything about my local data. So you just click on this files folder symbol. The left side, there is a file symbol is there. Okay, it will connected me to this thing. And now there is a upper arrow key. Upload your files. Click on this. Go to your folder where your data is there. My data is here. Open this. It will show you a warning. No problem. Now my data has come here. My data has come here. Python, we are going to import some libraries. First thing what we require to know this particular machine learning or data science is we should learn two important packages which is called pandas and numpy. These are the packages which deals with the numbers. So we need to import the library called pandas and numpy. And we may be plotting some graph. For that, we have to import matplotlib and cbon. These are the packages. Okay. And there is very important famous package called sklearn. We call it as sklearn or sklearn. And it has numerous amount of packages. So we import some of the packages like a time test split, a linear regression. Which model we are going to use? Linear regression model for to find out the mean square error, all these things. So these are the packages we try to import. Okay. I will share this file with your coordinator after the session is over. Don't worry about it. Then we are going to load our data. Now we have already saved our data in the Google Cloud. To this particular software, to my program I am going to load, I say that PD, which is a pandas, read CSV. The database name is salary-data.csv. Okay. After reading, this goes to an object called df sales. It goes to an object called df sales. Now we have done this. Now here you go and press the run button, and it will show you a tick mark. You can see the tick mark. So the tick mark, it is there. Okay. Please tell me the screen is visible. Second is import the data. I'll try to import the data. When I say that, so the object now is df underscore salary, sal. Now I say df salary.head, along with the header, it will display the data It will display the data. Okay, some data, 4 columns or 5 columns, it will try to display the data. Okay, now I don't want to do any kind of analysis. What kind of analysis we can do it? I can go say that describe my data. Already I have a data df underscore scale object. Describe my object. It says that the count, the number of data count is 30. Salary is also 30. The mean year is 5. Standard deviation, minimum. What is the minimum experience? What is the minimum salary? What is the 25% value of this maximum salary? What is the 50%? What is the maximum salary? Years of experience. All these things it shows. It is not required. We need not do it. What is very important? The importing the things and importing our data is a very, very, very important. Then let us go for plotting the graph. So we are using two things. One is the matplotlib and the cbon. Matplotlib and cbon. So we use plt, which is a object of matplotlib. We are setting the title for the graph, and we are using distributed plot from the SNS graph using the salary. Only using the salary df scale, we are taking only the salary column of the data, and we show plt.show. And you go and run this. Just a minute. Sal. Yeah, I'll just check that. It was working. What is exactly the problem is that? All these things comes, but anyway, I'll just check it up. Okay. So it could be just for plotting this graph. Yeah, now it is come. So this is for the salary, which density of salary, what is the range of salary which is the commonly occurring, all these things. A distribution graph. Years experience, the same thing, where exactly by dense year of experience is lying between 2.5 and 10. And I want to draw the graph between this salary and experience. I'm drawing what is called the scatter plot. So these are all not important. Very importantly, start here. We have to split the data. What is the splitting means? Between the training dependent and which are dependent, which are independent. The first column X is independent. The second column Y is dependent. So I am just splitting this X and Y. This is the first step. First step is to import the library, load the CSE. That's all. All the other things we are just doing it for ourselves only. Where the real thing starts? The real thing starts by splitting the data X and Y. Okay. So ILOC, everybody knows about this Python function. It split the column wise, slicing the data column wise. The second step is that we use upon all the data what is available. Some data we are for training the model. Some data we are going to use for testing the model. Similarly, some prediction is going to be output for the training data. Some output is going to be for testing the data. So we have 4 variables: capital X underscore train, X test, Y train, Y test. We are going to split the data. Okay. Like 20/80 we are going to do it. Test size is 0.2 means 20%, 80%. 20% is going to be for testing, 80% for training. We should train the model very more. Okay. So we just train the model. Then here we are calling linear regression. From where exactly it is coming? It is coming. We already included a header file, sklearn linear regression. We are just going to call this function from the library a linear regression. The variable is regressor is equal to linear regression. And the regressor, we are going to first parse training data and the test. 80% the training data, and we'll be getting 80% of the tested training result we'll get. So just if you go and run this, we get this. The model is linear regression. Now everything is over. Now we have to predict. Now predict is regressor. Regressor is what? The variable here. The regressor dot predict x data. For every x data, you predict it. Similarly, for every x training data, you predict it. You do the prediction for both training data as well as the testing data. Then you want to visualize your prediction. Okay. So similarly, use your scatter plot. Here, you say that X label is year of experience, Y label is salary, and you use this particular data into this X train and Y train. Draw the scatter plot using X training data, Y training data. X is the input, Y is what is called the output. Okay, so we'll try to run this. So you can see here, our data is above and below. During the training, the prediction, this is the actual ideal prediction. Some predictions are very close. You can see this point is very close to our prediction. This point is lying on the prediction, very good prediction. But not all the predictions are correct. Some of our predictions are lower than the actual value. Some of the predictions are higher than this value. Okay, so some of the predictions are higher than this value. Now, the same thing we are doing. This is for training. The test data, 20% the test data. It's the same thing we are doing. Instead of X train and Y train, we pass X test and Y test. We run this. Now you can see that with so much of training data, 80% of the training data, this is the output we get. With 20% of the test data, the model has trained very well. Sir, how do you say that the model has trained very well? You can see that the prediction is very, very close. Except 1 or 2 points, the prediction exactly is lying on the screen. So as you increase the learning, the testing will also try to improve it. Testing is also try to improve it. Now we are going to find the mean square error. Again, a package is available from the sklearn.metrics. Import it just to calculate the mean square error, which is around 12%. What is the accuracy? You can take the accuracy using a function called R2 score. So R2 score, what are you going to do? X test and prediction. What is the difference between the testing prediction and actual prediction? That is accuracy. Now, if you run this, it says that the accuracy is 99.0. Now you can see here, there are 1, 2, 3, 4, 5, 6 data is being used for testing, out of which 1 is very close, 4 are almost same as prediction, only 1 prediction is error. So 90%, 99% of our prediction is absolutely correct. Like in the theory, we have predicted coefficient A0 and A1. Here to predict the coefficient, we have predicted this. We have predicted this. So this is what is called a linear regression. How to predict the value, this is what is called the linear regression. Is it clear? Should I have to go for some other examples? Audience, can you respond?
Participant, any queries? Saida ma'am, are you raise your hand? Any queries, ma'am?
Okay, I will go for the second one. This is one dependent, one independent variable. Let's go for what happens if there are multiple independent variable. Y equal to a naught plus a1x plus a2x plus a3x, like this, x1, x2, x3. Multiples of thing. Then how can I do that? Same. The procedure is almost the same. Only thing is I am going to use a different data. I'll show you the data. Let's say car data. I have the type of car, the model, the volume, what is the size of the car, what is the weight of the car, how much of carbon dioxide emissions that is the car is giving. Okay, so this is what is exactly the data that I have. So giving this data, the independent variable, it should predict what type of car it is. That's what exactly. This is my car underscore data CSV file. So what I do is that, as usual, it is connecting. That's okay. Now I just go and upload my local data, car data.csv, into Google Colab. That's right. We'll try one more time. Yeah, it has come. Car data.csv, it has come. As usual, you import this. I already told you that to import all the packages what you need. First step, run it. Wait for a tick mark. Yes, there is a tick mark. Second, read the CSV file. pd.read, pandas.read underscore CSV. What is the data? car.csv. Store it in a data frame. df is the data frame object. Now try to print first 4 or 5 columns, df.head. You want to describe it, the data, you can describe it. You will get the average, count, mean, standard deviation, everything else. Actually, it's not required. And what is x and what is y? We have to define. Now, the previous problem, we know very well, there is one x value, there is only one value, y value. But here, the x values are so many. Okay, so which are the x values we are going to take? We are going to take weight and volume as x values. The data frame, the column name will weight, column name will volume. These only we are going to take. And y is this CO2. Depending upon your volume, depending upon your weight, how much of carbon dioxide emission is going to be there. Okay, we have run it. So you want to plot it, not required to plot, not required to plot. Now to check whether my data is not outside my region or any, it's called an outlier. Just go and run this. Now my data is very precise. There is no data out of the range. Everything is inside the range of this 1400 to some about 1000, let us say 1100 to 1400. Similarly, volume 1500 to 2000. My data is only in this range. Now, if you want to display the plot, you can display the plot. Not required for the project. All these things are not required. This is only for plotting. This is only for, now our actual building model starts here. As usual, X train, X test. X train is used for feeding the data for training. X test is used for taking the input for the testing. Y train is output of training. Y test is the output of testing. You split it. You split it like this. Train underscore test underscore split is a function, built-in function. X value, Y value, we already defined XY value. And 30-70. 70% training, 30% testing. Test size is 0.3. Okay. And you just take this, run it. And you want to know how much it is. Out of that, 25 rows are taken for the training. 11 rows are taken for the test. Okay. So what is the model we are going to use? Linear model, linear regression we are going to use. Only thing is multiple regression. For multiple regression, same. It's also linear regression, but one more step we are going to do. What is that? This linear regression dot fit X train and Y train. Because in the previous things, we have not done this. We know only one X value, one Y value. Now we are going to have multiples of X value. So we have to say fit into the linear regression, the X train values and the Y train values. Now you try to find the intercept value. The A0, A1, A2, no? We try to find the intercept value. We got an intercept value. Now you go for a prediction. First, go for testing, then you go for training. First, input the test data, you get the Y prediction. Then input the train data, you get an X prediction. Prediction of this particular thing. Okay, so just do the prediction of this. So we get a prediction value for all these things. So our model is working. Okay, so now what is the actual value and what is the predicted value? Let's go for that. So actual value is 99, prediction value is 90, 105, 102, 104, 99. So this difference is what is called a mean square error. It's called a prediction error. Okay, this is called a prediction error. So we will do the metrics also, what is the accuracy, etc. We do that. You can see here the mean absolute error is 6.9. The mean square error is 6.3. The root mean square error is 7.96. That means the model still has to learn more to reduce this particular error. The model has to learn to reduce this particular error. Is it okay? So can I close, or you want to have one more examples, the medical data? Please give your feedback. Shall I stop here?
One second, sir. Any queries or any feedbacks from participants? Any queries?
Abraham Sayanda has raised the hand. May I know he has a... There is one participant has raised a hand to ask questions, it seems.
Yes, sir. Saida ma'am, any queries, ma'am? Okay. Thank you, sir.
Okay.
Sir, it's audible, sir.
Yeah, before I just go that, since it is a medical, medicine learning with respect to medical, I also have what is called one more data sets, what is called a heart attack data set. Okay.
Yeah, okay, sir.
Heart rate prediction data set.
Yeah, okay, sure, sir. Proceed, sir.
Okay. No, just tell you that the same thing, you know, whatever we have done for this, same procedure is first to go and open the Google Colab and then wait for the connection to happen. Now upload this particular data to your thing. So it will be uploaded, depends upon internet speed. Okay. Now as usual, import your packages, read your data. You describe the data if you want. It's not important steps. Now some of the thing like the chest pain, which has a different rating, a TA, ATA, and AP. I am trying to put it as TA as 0, medium level, medium severity 0, low severity like this 0, 1, 2, 3 severity. I'm replacing with numbers because it will be very easy for me to work with the numbers. So I'm just replacing it. And so once I have the correlation value between all these things, now this is what is called the heat map. You can create heat map just simply saying that SNS.heatmap. SNS is what is called our library we have included. Seaborn library. SNS is Seaborn library. And using that, you can create a heat map like this, just for visualization, And what is the dependent variable? What is the independent variable? And the trained data, now we are going to use the linear regression, and we are going to fit the train and test data. Okay, so you can see this is the coefficient I get, and I can so prediction comes here, and now I am plotting the prediction graph. You can see in the graph, these are the points, these are the actuals, and my prediction is very close. Is very close, and you can see that the absolute error is only 20%. The absolute error is only 20%. Okay, so this is regarding to medical. So thank you very much for giving an opportunity. I had a wonderful time with you, apart from my regular teaching. Thank you very much, the organizers.
Thank you, sir.
Okay.
And thank you for sharing your valuable insights, sir. Thank you all. Tomorrow's sessions start will 5 p.m. Thank you, sir. Thank you so much, sir.